physics fans, welcome to this fine Friday morning. A little snow going on out there, but hopefully it's not going to give us too much. Hopefully by tomorrow everything's going to be gone. The weatherman said it's going to be warmer tomorrow and it's going to continue to get warmer next week, so hopefully we can get some nice weather here. We have finished up chapter 8 with the notes. I'm going to post some homework today. That will be due on Tuesday. I have a review sheet on Monday. We'll have a chapter 8 test on Tuesday, and I'll talk about that more as we go into next week. I have some homework problems for you. Once again, they will be due on Tuesday also. I want to go over one last buoyant force problem here in regards to, let's see, we have a raft with a length of 3 meters, a width of 1.5 meters, thickness of 0.12 meters, and a density of 750 kilograms per meter cube. Is placed in a river. How far below the water's level surface does the bottom of the raft sink? Well, we all have sat on rafts on the lake or in the ocean or in a river, whatever. They don't sink to the bottom. They float on top. So what happens when we float on top? Well, if we have a water level here, and we put a raft in the water, some of it's going to go down below the water surface. Some of it depends on what the density is and what's the material made out of, what's the weight of it. It may go a little bit below the water level, okay? But it's not going to go entirely below the water level, okay? So what happens here is, well, you have the force of gravity of the weight of the raft, but you also have this buoyant force that's going up. Well, if it's not moving in the water, it's just sitting there, it's not going any further down, it's not going up out of the water, what has to be true about these two values? That's exactly correct. They have to be equal. So the buoyant force has to equal this force of gravity, which is the weight. Well, let's look at the right-hand side first, because that's a little bit easier to deal with. Well, how do we find the weight of this raft? Well, we have to take mass times gravity to find the weight of the raft. Okay, we have to find the weight of this raft, mass times gravity. Well, we're not given the mass, but we're given the density of this raft is 750 kilograms per meter cubed, and we're given the dimensions of this raft, which allows us to calculate the volume of the raft. So we can calculate the volume of this raft by length times width times height. So my length is 3 meters. My width is 1.5 meters. And my depth, or my thickness, is 0.12 meters. So if I multiply these all together, 0.3 or 3 times 1.5 times 0.12, we get 0.54 meters cubed. That is the volume of this raft. Well, how do we calculate the mass though? I know the volume, I know the density. Well, mass is equal to density times our volume. So our density is 750 times 0.54. So if I multiply these together, times 750, we get 405 kilograms. So we have the mass of this as 405 kilograms. So we have 405 kilograms times our gravity. And I'm not going to multiply by gravity right now because I'm going to be working on the buoyant force also. And the buoyant force will also have the idea of gravity in there too. So we have both of these that I could work on the other side here that's going to take care of my gravity. If I wanted to multiply this out, I could do that, that's fine. I can multiply 405 times 9.81. And we get 3973.05 newtons. That is fine. Or if I can leave it as G, that is fine too. Now the question is, how do I find this buoyant force? Now if you remember back, this buoyant force is also equal to the weight of water displaced. The weight of the water displaced. So if we take a look, okay, I know if we're talking about a lake, we put a raft in there, the lake level is not going to go up very high, but they'll have a little bit of displacement here. Okay, what I'm going to do is this amount from the water level down, I'm going to give that a value of y. Okay, I'm going to give that a value of y. Well, if we think back to our ideas in regards to Archimedes, the weight of the water displaced is also equal to this buoyant force, okay? And the weight of the water displaced is also the volume of this object that's below the water. So the volume of this water that's below, or the raft that's below the water, is also equal to the volume of the water displaced. So volume of object below water. So this volume of this object below the water is also going to equal the volume of the water displaced. So if we take a look, if this is a value of y, that's how far below the water. We have the bottom of this raft has dimensions of 3 by 1.5. So my volume of the object below the water is going to equal 3 times this 1.5 times this value of y. Now this value of y is what's going below the water. So if I multiply 3 times 1.5, I get this volume is equal to 4.5 y. Now, just like over here, we can find the mass. The mass can be calculated by our density times this volume. Well, here we're going to be talking about the density of the water, which is 1,000 times 4.5 y. So this mass that we have is equal to multiplying this out, 4,500 y. Now to get the weight of this water displaced, which is also the buoyant force, they are the same. Your weight of water displaced weight of this water displaced is also the buoyant force. We can multiply this mass of this water displaced times gravity. So the weight is going to equal 4,500 y times gravity, which is 9.81. And like I said, that's why up here I didn't really want to multiply by g, but I still did. So if I multiply 4,501 or 4,500 times 9.81. We get 44,145 Y. Now these two things have to be equal. This value here, the weight of the wad or the weight of the raft has to equal this buoyant force because it's just sitting there. So if I set these things equal, we have 44,145 Y is equal to 3973.05. And if I divide by the 44,145, so we have 3973.05 divided by, let's see, 3973.05 divided by answer. We get a Y value of 0.09. So if we take a look at our raft, this amount of distance that is dropped below the water is 0.09 meters. Once again, the key idea here is when things float, that means the buoyant force is equal to the weight of the object. Okay, because that's the sum of the forces in the y direction, they have to be equal. And we can utilize that to be able to come up with how far below the water surface the object goes. Also knowing that the buoyant force is equal to the weight of the water displaced, which allows us to deal with Archimedes' idea, the volume of the object below the water is also equal to the volume of the object displaced. And knowing the density of that fluid, we can then calculate the weight or the mass of the water displaced, which allows us to give us the weight of the water displaced. Okay, you have a problem like that on your homework, so you can refer to this to be able to assist you. Once again, the homework will be due on Tuesday. I'll get a review sheet posted. I'll try to maybe post it this weekend in regards to the material. That will be Monday's assignment. We will have a chapter test on Tuesday over this material. Once again, please do keep up with the material as we go forward. So if you have any questions, once again, feel free to make comments or email me. I'll assist you as best as possible. Stay safe. It's Friday. Enjoy the weekend. Hopefully, once again, the weather will get a little bit nicer for us out there. Enjoy your weekend. Stay safe. Keep your social distancing. They say it's working. So let's continue to do that and do our part in regards to this so we can get back to some sort of normalcy. Once again, if you have any questions, please feel free to email me. Once again, I miss you guys. I wish you were in the classroom, but you know, it's our reality. So we'll just make the best of what we have. But once again, please do keep up with the material. I have no exit tickets here for this. There's no other evaluations you have to do this week. If you've not done some of the evaluations, please go back and get them done and get them completed. Start doing some catch up because some of us are not quite there and have not kept up with the material. So please catch up with the material that we are dealing with. And you can do this. I have faith that you can do this. It's a growth mindset that you can handle education in this form. It's a little bit different, but you have to be disciplined in regards to getting material done. So you just have to keep up with the material. Once again, you can go back at any time and redo any of the notes, look at any of the notes, get anything done that you need to get done. Other than that, adios. I'm out of here. You folks have a great weekend. See ya. I miss ya.